Yeah, that'll do it. As I said, I have really good news. If you did not hear, the notes only take one side of a piece of paper today. I know, it's a Halloween surprise. Actually, it just landed on this. Um, this lesson is two things that you already know. It's, guys, uniform density function, which is that rectangle one, and then normal CDF. And that's it. That's all we're doing today. It's very easy. That's why I said chapter 2 review. Okay, anyway, so continuous random variables. We did discrete the other day, meaning that there's gaps between the numbers, right? And continuous ones are called density curves. And we already studied that. Okay, and this should make sense to you because I back in chapter 2, I told you that all density curves have to add up to 1. Do you remember that? So, do you guys remember me saying that? No? Yeah. So underneath the normal curve has to add up to 1. Underneath the rectangle has to add up to 1. Okay. There's 3 types for us, uniform. And that one is the one that's a rectangle, and we studied it already, but we're going to do one right here to remind ourselves how to do it. Normal, where we're going to use normal CDF and inverse norm to calculate stuff. And then sometimes we had skewed ones. And those are really hard to calculate stuff for. We're going to do some skewed ones later on in the chapter, but not today. Okay. If it takes Selena 4 minutes to get to work using the airport walkway and between 2 and 5 minutes to take the airport train, use a uniform density function to find the probability that it's quicker to take the walkway. Okay. So I'm going to make my so do you guys see how this goes up to 5? The highest number is 5 in my problem. So I'm going to make my axis go to 5. And the label will be time to get to work. And before I told you that the rectangle, you would take area equals base times height, and you would do area would be 1, and then you would take the base and plug that in to get the height. And we're going to do that still, except for this one doesn't go to 0. So I want to draw my rectangle first, is what I'm saying. So it says, if it takes Selena 4 minutes to get to work using the airport walkway and between 2 and 5 minutes to take the airport train. Okay, so the greatest span, the least number mentioned in the problem is 2, and the greatest number mentioned in the problem is 5. So I'm going to make my rectangle go between 2 and 5. And I'm going to make it 3 tall, not really for any reason, just it's just supposed to be a rectangle. It doesn't really matter the height. I'm going to label the height, but I'm just making it 3 tall to make it look nice, really. It's just an aesthetics thing. Okay, so remember from chapter 2, we said area equals base times height. And the area always has to be 1 because it's a uniform density function. Any density function, the area is 1 for the total. And the base is 3. Does that make sense to you guys? Okay. Thank you. Okay. And now we have a bit of logic to figure out in this question. What's the zone in my rectangle there that I made that it would be quicker for her to take the walkway? Okay, take 30 seconds, talk about it in your groups, figure out what part of the rectangle satisfies the question it's asking, which is when it would be quicker to take the walkway. Go ahead, give it a go.
Yeah, I agree. I agree with
I think it's like everything else. Does anyone have an intelligent idea of what part of the rectangle I'm talking about? Okay, so let's do it this way. Let's do process of elimination. If it takes her 2 minutes to get to work, is she using the walkway? No. Yeah. Well, 4, right? If it takes her 3 minutes to get to work, is she using the walkway? No, she took the train. Okay, read this. It says, okay, if it takes Selena 4 minutes, it takes her 4 minutes to use the walkway, and between 2 and 5 minutes to take the train. Okay, so if she got there in 2 minutes, she took the train. Okay, if she got there in 3 minutes, she took the train. If she got there in 4 minutes, it could be either one, right? Okay, but what about 4.01 minutes? What would be faster? The walkway. Okay, so the only place where she should use the walkway is if it's going to take her between 4 and 5 minutes. Anything greater than 4 minutes, she should take the walkway. Okay, so it's like you walk up and you're like, it's like those signs when you're driving on the highway and it's like, takes 20 minutes to get to SFO, right? So you're like, oh, should I do this or this? So she's walking up and she's like, it says it's going to take me over 4 minutes. If I take the train, I should take the walkway. If it says anything less than 4 minutes, then she should take the train. Okay, so the issue here is between 4 and 5. This is the region where she should definitely take the walkway. Okay. Now, the actual thing I want to teach you in this lesson is notation. And you did some notation in your homework for 6.1a, but we want to say the probability, and I'm just going to say X because I'm a math teacher. So that's my variable of choice. But X is greater than 4. If the time is greater than 4, then she should take the walkway. Does that make sense? Okay, so we want to find the area of this rectangle. The base is 1. The height is 1/3. So the probability is 33%. The math on that, super easy. Deciphering the problem, not easy. Okay, and then this is the end. My friend. Real quick, in my video, there's Miss Maselli from across the school. In case you didn't get to see her today. Well, Miss Rice is discussed. And Miss Franco is Joy across the hall. Well, it's sort of not, okay, so it's kind of anticlimactic, but Miss Rice is discussed. She looks amazing. It's perfect. It's absolutely perfect. Miss Franco is Joy. Mr. Knight doesn't do Halloween. Yeah. Yeah. No, he doesn't do. Mr. Regalado was supposed to be Anger, but he thought that his wife was buying the costume and she thought that he was buying the costume, and then they woke up this morning and neither of them bought a costume. But if you see her today, she's Cookie Monster and adorable. Adorable. And then Mr. Keppen is Embarrassment, and we didn't even talk to Mr. Guinan about it because we didn't think he'd want to do it. Oh, and Miss Maselli said.
Right.
He was going to be Fear. He was assigned Fear in our group thing because I thought that it would be perfect because he's skinny and like the sweater vest. And then we just didn't even he
Well, you got like half of them.
No, it's not that. It's just that we knew he wouldn't want to be bothered. Yeah, it's fine. I wanted to be ennui though. Like, but this makes more sense. Okay, guys, let's finish it up. Please grab your calculators. Shh. I'm so close to being done, and then you can chat it up. I lost my calculator over here. Okay. All right, so first thing I need to do is remind you that that's a thing and where to find it. It's in the second VARS menu, which is the distribution menu. Second VARS. Second one down. And remember it goes low, high, mean, standard deviation. So low, high, mean, standard deviation. And this is how you should write it. Is it coming back to you? Yeah, I don't know how to fix it. I gotta Google it. I've just been so busy. Okay. Now, next question is, how do we do less than? Do you remember? Yeah, okay. Yeah, okay, so remember, see how your arrows, shh, do you see how your arrow's going this way? Your crocodile is, okay. So that means that the low is negative infinity because it's talking about less than 67. So the low is negative infinity. The high is 6, 7. Yeah. Uh-huh. You guys are so lucky because I say that 1,000 times in all my other classes. They're telling me to stop. Okay. Guys, please, I just really want to be done. You're talking over me again. Thanks to you. Okay, so now that we've reviewed this, how do I do greater than? Yeah, yep. But that's the high, right? Okay, now I want to say one more thing real quick before we and it's something I told you in chapter 2, but I want to say it again because you'll probably forgot. But it does not matter on these problems if it's greater than or greater than or equal to. Do you remember that they were talking about an area? The boundary doesn't have any area. So if your problem says greater than or equal to, or less than or equal to, or something like that, it's not going to change the problem at all because the line, and the line doesn't have area. Do you remember what it was when it was equal the number? Do you remember that? It was 0 because it's just a line and that doesn't have any area. So just in case that happens, I want to throw that out there, but don't freak out. These are your only options for normal CDF. So if the or equal to is there, it doesn't change anything. The question is, do I have a joke? Oh, you're the best. Oh, you gotta say he's him. What? Say he's him. What does that mean? You're who? You're him. Like, you're Timothy. Like, say you're him. No, it's like saying like, oh, he's that guy. Oh, you like he's that guy. Oh, he's him. Yeah. That's awesome. Okay. I do have a joke. It's pretty good. So there was a period of time. So 6, 7 is like the thing now, but there was a period of time where there was a particular meme that was going around, which it's like what incarnation? Then you get a hat on it. Yeah. There was a period of time, it was a few years ago, where, yeah, where they would take anything and just say what and then it ended in TION, and then they would put a hat on it and a meme, like, it was just a thing. And back when we had Vice Principal Sean Thompson, there was a meme going around of him that said like, and then it had the hat on him, and it was like, what in the, I can't remember. And this was like you explained. Yeah. This is a while ago. Anyway, he used to say something with like TION at the end, and then that wasn't the. Oh, no, it's just like one of the principles, but the president or something, the. I gotta try to find it. Anyway, I promise you it'll be funny. This is funny, it's fun. I don't, yeah, I'm making me nervous. Do you guys remember my? Yeah.
I didn't know you got that.
Before. Realize that, like, you haven't seen him in school.
I think that's what you mean.